Good morning to all. Let us today discuss the differentiation in physics. What is the meaning of differentiation and what is the use of differentiation in physics? Now, differentiation is a part of science of calculus and was first developed in the 17th century by the two different mathematicians, that is Leibniz and Sir Isaac Newton. Differentiation or finding the instantaneous rate of change is an essential part of mathematics and physics, chemistry, biology, computer science, engineering, navigation, and astronomy. Calculating speed. Now, as you know that from this you can easily find the speed. Speed is equal to distance upon time, or distance is equal to speed into time. Time is equal to distance upon time. Now from here, let us discuss the graph. This is a graph between distance and time. Now from the graph, let us find the speed for each section of the journey. Now speed in A, that is speed during this point. The distance upon time. Now from this graph it is clear that distance is 4 and time is 3. So speed in A is 4 by 3. Speed during B is 5 upon 1, 5 meter per second. Speed in C, that is during this section, distance is 2 and time is 5, so 0.4 meter per second. Average speed, the total distance upon total time. Total distance 4, 5, 2, that is 11. Total time 3, 1, 5, that is 9. So total average speed is this one. Now notice the following things. The instant speed, the speed at each instant is not the same as the average. This is different, this is different, this is different, and average is 1.22. Speed is same as gradient. Now one more thing, gradient means that is the slope. This is the slope. Speed is equal to distance upon time. So we can say that del y upon del x is the gradient, gives you the speed, or the slope of the graph gives you the speed. Now instantaneous speed. Now you actually in reality the speed does not often change instantly, means there is no sharp turns. The graph on the right is more realistic as it shows a gradually changing curve. So this is the more realistic graph and this is unrealistic graph. The journey has the same average speed, but the instantaneous speed is different at each point because the gradient of the curve is constantly changing. So instantaneous speed is different at each point. Now the question arises, how can we find the instantaneous speed? Let us discuss. Now differentiate means find how fast something is changing in comparison with something else at any instant. For example, the speed, the rate of change of distance with respect to time, del t upon del t. Acceleration, rate of change of speed with respect to time, del s upon del t. Gradient, rate of change of y coordinate with respect to x, del y upon del x. So differentiate means find how fast something is changing in comparison with something else at any instant. Now let us discuss to find to estimate the instantaneous rate of change. Now the diagram shown below attempt to estimate the instantaneous gradient, that is the rate of change of y with respect to x at point A. Now this is the point A. So gradient at point A is del y upon del x. Now look here clearly that as del x is reducing in the second graph, del x is less than del y, then the point, if you give the name this point to B, this B come closer to point A. As in this graph, B point is more closer to A and del x is more smaller. So notice that accuracy improves as del x gets closer to 0. As del x comes to 0, B point comes to near and the point becomes the instant point. So a point becomes the instant. So the instantaneous rate of change is written as dy by dx or del y by del x as del x approaches to 0. So when del x approaches to 0, then del y by del x is known as the dy by dx or the instantaneous rate of change. So the basic differentiation, what can we say? That instant rate of change of y with respect to x is written as dy by dx. Now by long experimentation, it is possible to prove the following. That is, if y is equal to x raised to power n, then dy by dx will be n x raised to power n minus 1. So let us see how to differentiate. Multiply by the power is n, so multiply by the power n, multiply by the power is n, so n, and reduce the power by 1, that is n minus 1. So now dy by dx describes both the rate of change and as well as the gradient. So dy by dx gradient or the slope. So it describes both the rate of change as well as the gradient. Now differentiation of the expression with multiple terms. Now if you have the expression y in which there are the multiple terms, then how we can differentiate? Important point, so listen it carefully. The process of differentiation can be applied to every x term in the algebraic expression. So first of all, the expression must be written as the sum of individual terms before differentiation. So separately we have to write each and every term. Then to differentiate, कैसे differentiate करेंगे? Multiply every x term by the power, reduce the power of every x term by 1. That is a m x raised to power m minus 1 plus b n x raised to power n minus 1 and so on. For example, let us understand it by the example. If y is equal to 3x raised to power 4 minus 5x raised to power minus 3 plus 7 upon x square plus 9, then find dy by dx. So let us reduce the terms like this. 3x raised to power 4 minus 5x raised to power minus 3 plus 7, take the x square to the numerator, that is x raised to power minus 2 plus 9. Now 9 can be written as 9 in x raised to power 0, because x raised to power 0, anything having power 0 is always reduces to 1. So in 9 into 1, or that can be written as 9 is equal to 9 x raised to power 0. Now when you differentiate, so what will be 3x raised to power means 3 into 4, 12, and reduce the power by 1, x cube. Here minus 5 minus power is 3. So minus 5 into 3, that is 15, and power reduces by 1 is 2. Here 7x raised to power minus 2, so multiply by minus 2. So minus 2, that is minus 14, and reduce the power by 1, so x raised to power minus 3. Here power is 0, so when you multiply it by 0, so it will be 0. Or in other words, you can remember that whenever you differentiate the constant term, the result is 0. So the final result is 12x cube minus 15x square minus 14 upon x cube. Now let us understand with one more example. Find the gradient of the curve y is equal to this at the point 5, 0. Now first of all, we have to reduce this expression. So how we will reduce this expression? Multiply the numerator x square minus 2x minus 15 upon x square. Now separate all the terms. This will become x square upon x square, that is 1, minus 2 upon x minus 15 upon x square. For multiplying and separating the term, you have to use your previous knowledge. So now this further reduces to 1 minus 2 x raised to power minus 1 minus 15 raised to power x minus 2. Now differentiate. So 1 is a constant term, it's 0. This term is 2x raised to power minus 2, and this is plus 30x raised to power minus 3, or 2 upon x square plus 30 upon x cube. Now we have to find the gradient at point 5 and 0, that is x is equal to 5 and y is equal to 0. So x is equal to 5, value, put the value and get the result. Now, derived function. It is also possible to express differentiation using function notation. It is the same thing. If fx is equal to x raised to power n, then f dash x is equal to n x raised to power n minus 1. So f dash x means the derived function. So either write f dash x or dy by dx. Both have the same meaning. F dash x by used by the Newton and dy by dx used by the Leibniz. So both have the same meaning written in different ways. So the word derived means or the produce from. For example, orange juice is derived from oranges. The derived function f dash x is the rate of change of the function fx with respect to x. Now, tangent to functions. A tangent to a function is a straight line which intersects the function in only one place with the same gradient as the function. As you know, the tangent means the line which touches any curve at one single point. So here AB is the tangent to the function fx, and MAB, that is tangent, is MAB, and this is the derived function f dash x. So tangent to a function is a straight line which intersects the function in only one place with the same gradient as the function. So gradient is f dash x and tangent is also touching the curve at the same point. So we can say MAB is equal to f dash x. The gradient of any function to the tangent can be found by substituting the x coordinates of the intersection into f dash x. So let us discuss it with the one example. The equation of the tangent. Now, as you have studied in the previous classes, that equation of the straight line is y minus v is equal to mx minus a. So to find the equation of the tangent, for we will do, these are the steps. First, differentiate. Second, substitute x coordinate to find the gradient of the function point of intersection, and then substitute gradient and point of intersection to the line. Let us discuss it with some example. Now question is, find the equation of the tangent to the function fx is equal to 1 by 2 x cube at point 2, 4. So function fx है, f dash x क्या निकलेगा, that is differentiating it. Differentiate में use the same formula, that will be 3 by 2 x square. So if m is equal to f dash at the point of intersection is x is equal to 2. So put the value of x is equal to 2 here and get the value of m. So this is the value of m. Now here put the value of m and value of point. X is equal to 2 and y is equal to 4, that is a is equal to 2 and b is equal to 4. So put the values and you will get the equation of straight line, which is the equation of a tangent. Now, increasing and decreasing curves. You have seen many curves which are increasing at some point. Just look at this figure. So the gradient at any point on a curve can be found by differentiating. If dy by dx is greater than 0, it means y is increasing. If dy by dx is less than 0, then y is decreasing. From here also you can say that is the uphill slope and this is the downhill slope. Or alternatively, we can say that if f dash x is greater than 0, then fx is increasing. F dash x is less than 0, then fx is decreasing. From here the slope is decreasing, so this is dy by dx is less than 0. Here dy by dx is greater than 0, so slope is increasing or y is increasing. Now, stationary points. If a function is neither increasing nor decreasing, the gradient is 0 and the function can be described as stationary. So when it is neither increasing nor decreasing, means not greater than 0 or not less than 0, it means it is equal to 0. So there are the two main types of stationary points. At the turning point, the stationary point is minimum. In this case, the turning point is maximum, means decreasing, increasing. In between, the point is minimum. Increasing, decreasing means the point is maximum. And point of inflation means if it is increasing and then increasing in other ways, decreasing and decreasing then falling. So at any stationary point, dy by dx is 0, or alternatively we can say that f dash x is equal to 0. Now investigating stationary points. Example. Find the stationary point fx is equal to x square minus 8x plus 3 and determine its nature. Now, a stationary point is given by f dash x is equal to 0. In the previous slide I told you that stationary point f dash x is equal to 0. So, f dash x means the differentiation of it, that will be equal to 2x minus 8. इसका 0 हो जाएगा, इसका minus 8 हो जाएगा, and this will be 2x. So 2x minus 8. If you equate it equal to 0, you will get x is equal to 4. So now using this x is equal to 4, make the table that x, fx and slope. Now at x is equal to 0, so slope is straight line. If x is slightly negative, so just look at this figure. If x is slightly negative, then what will be the result? The total result will be negative, that f dash x is negative. Look again, if x is negative, slightly negative, then the value will be equal to negative. So slope is decreasing. And if x is slightly positive, then this will be greater and the result will be positive. So gradient is positive, and positive gradient means increasing. So here it will be like this, decreasing, increasing. So the point at x is equal to 4 is the stationary point, and it is a minimum turning point. It is the minimum turning point. So that is all for today's lecture.